It powers your phone, it powers your house, and for some people, it even powers their thinking. But how does electricity actually work? I've been doing a lot of micro-robotics lately, and I keep running into the same thing. A lot of programmers don't really understand hardware. And honestly, that's fair. Electricity can feel pretty abstract. So today I want to give you a simple mental model that I use in order to understand electricity. We'll clean up the details at the end, but first, let's make this intuitive. I think of electricity like water. When you connect a wire to a battery, it's like attaching a pipe. You've given the electricity somewhere to go. But just having a path isn't enough. Nothing moves unless something is pushing it, whether that's gravity or some other force. That push, that pressure when we're talking about electricity, is what we call voltage. All electricity will have some level of voltage. It is just a fundamental fact of how it behaves. So when you see something like a 5-volt battery, that's not how much power the battery has, it's how hard it pushes electricity through things. And this is the most important part of trying to build with electricity, because every device is built to handle a specific amount of that pressure. If the voltage is too low, nothing really happens. If it's too high, you break things. Think of it like putting a glass under a faucet versus under a waterfall. Both are going to fill the glass, but one is going to absolutely shatter it. Same idea, similar results. The electricity flows through the wire into whatever you connected, and the device uses that energy to do what it was designed to do. A light will turn the electricity into light. A motor will turn it into motion. Your phone turns it into everything that your phone does. Finally, there is one more very important part to this metaphor that makes me like it as much as I do. Just because a system can provide a lot of energy doesn't mean everything connected to it will take all of it. If the voltage was somehow correct, I could connect this little flashlight to something strong enough to power an entire city, and it wouldn't break. Because in this case, the amount of electricity is like a big pipe with a lot of water available. You can still take a small sip from it. A tiny device doesn't suddenly become dangerous just because it's connected to a bigger source. It only takes what it can handle. So long as the pressure, the voltage, is correct, you can power small things from much larger systems just fine. You can also find devices that change pressure. These are called step-down or step-up converters. The easiest way to think about those is like when you put your thumb over a hose. You're not creating more water, you're just changing how it comes out. So even if your system starts at something like 24 volts, you can safely power something that needs 5. You just have to reshape the pressure to match what the device expects. And as a small technical aside, if you ever do use a step-down converter, there is a tool called a multimeter, that you can use to measure voltage. I'd highly recommend using one before just connecting your device after you try to step it down. Alright, that's the main metaphor done. Now let's put names to everything we just talked about. Voltage is the pressure of the system. It's how hard the energy is being pushed, and it is what needs to match in order to connect electronics to power. Current is how much is flowing through the system, and that's measured in amps, or milliamps for smaller electronics. More amps just means more flow. A load is anything that uses the energy. So if I connected this flashlight to something, this flashlight would be called the load. And finally, we've got power. It's called watts. That is just how much energy is being used overall, which is pressure multiplied by flow, or voltage multiplied by current. You don't really need to memorize all of this to build basic electronics with an Arduino board. The main thing to keep track of is pressure, but I do want to have all of these definitions here because it makes the video feel more complete to me. There's really only one place that this model breaks. Electricity needs a complete path in order to flow. Unlike water, it can't just spill out, it has to return. That's why wires usually come in pairs. One will carry the energy out, and the other brings it back. If you don't create a loop, there is no flow. And one correction about current. It is true that your current can be as high as you want it to be as long as the voltage is correct. But I feel like I need to mention, the higher your current, the more dangerous it is if any part of your electronics fail. Not only is current what will turn into heat, but it's also the thing that's really good at stopping people's hearts. That said, in smaller electronics, you really don't have to worry about it, but that's why I wouldn't recommend hooking something like this up to the industrial power grid. So for microrobotics, here is everything you really need to know. If the voltage matches, and you've got a complete path, things usually just work. And once you understand that, you can start to see this everywhere. Take a car, for example. It has a battery, like we talked about, but it also has something called an alternator. And what that does is generate electricity while the engine is running. So instead of the battery slowly draining, the system is constantly being refilled as you drive. Which means the limit isn't electricity, it is your gas. Your home electricity works a little differently. Your home isn't powered by a giant battery. It's connected to power plants that are generating electricity in real time. So when you turn something on, like your microwave that is more power intensive, you're not draining a battery. Instead, you're increasing the demand on a system that is constantly producing energy. And those systems will adjust to match that demand in real time. You'll probably find this hard to believe, but the ability to store energy at a large scale is something we're only just figuring out. Historically, it's been very difficult and expensive. So as crazy as it sounds, it is actually easier for us when we create it as we need it. But no matter where electricity comes from, a battery, a car, or a power plant, the same rules apply. Voltage, current, and something using that energy to make something happen. And if you understand that, there's really no reason for electricity to feel abstract. It starts feeling predictable. You know, I actually find teaching content to be really hard to make. Because when I'm just making a video for fun, I don't really care as much if I say something that is a little bit wrong. In fact, it tends to boost engagement. But when I'm making a video where I'm really trying to explain a concept in a way that will help someone, then I'm always judging it by the standards of, if I could go back in time 10 years and watch this video, would my younger self understand what I was saying? And that's actually a pretty hard metric to live up to, because I always hate when people add tons of fluff and extra information that makes it hard to understand something in a way that I could actually wrap my head around. So yeah, I hope that this explanation helped you out. If you have any questions at all, feel free to leave a comment. I do keep these videos intentionally a little bit lower level, because I feel like the next logical step is recording a video of me making the system as like a step-by-step guide, and that's not really what I want to do so much as I want to try to help the people who just really need some clarity on what these difficult concepts are. Yeah. Anyway, back to some fun videos I'm probably going to record right after this. I don't know why, I was kind of struggling to talk through this one, but whatever. I hope you have a great rest of the day. If you were trying to make anything cool, please tell me about it. And yeah, until next time, see ya. God, this was hard. I was trying to make this an unscripted video, but I genuinely think that teaching content is very hard to do unscripted. Because a lot of the time when you're trying to dilute something into like a core concept, when you are unscripted, you tend to ramble a lot more and not get to the point. And especially with things that you know a lot about, that can kind of result in an overload of information where, even though it's all good information, it's hard to follow. Shit, there goes my battery.